Alright, we're going to start off this lesson by looking at a picture of a square and a rhombus. And the question is, are they congruent? We have a square, we got our rhombus, and we have the sides of the square the same size as the rhombus. Well, if you understand what congruence is the fact that they have to be the same size and shape, then you would understand that the answer is no, they are not congruent. And this is because ABCD does not map to GHIJ because the angle measures are not preserved. So they're not congruent because angle measure is not preserved. Size and distance is preserved, but not angle measure. It is not preserved. So if I overlaid the square ABCD with onto the rhombus, the A would not map to G, or I could get one point to map to the other, but the rest wouldn't line up. So here's a definition of congruence. When figures are congruent, this means that there is a rigid motion, or a composition of rigid motions, that maps the pre-image onto the image. And that rigid motion is called a congruence. Again, if you look up here, I cannot reflect or rotate or translate the square and have it completely mapped to the rhombus. So that's why they are not congruent. So the bottom half of your front page basically answers that. Under this definition of congruence, describe why the figures in the opening exercise are not congruent. You could say a number of things. All it takes is one thing. I could say angle ABC does not map to angle GHI. So the angle measure is not preserved. Now we can have a correspondence, and that does not imply congruence. So a correspondence between two triangles or any two shapes, it's a pairing of each vertex from one with one and only one to the other. So again, this statement talks about triangles, but then we also say that this pairing can be expanded to figures other than triangles and could also involve sides. So a correspondence basically is when you have the same number of vertices and sides from one image to another. So look at example 2. In the figure below, the triangle on the left has been mapped to the one on the right by a rotation of 240 degrees about point P. Identify all 6 pairs of corresponding parts, angles and sides. Alright, so basically I have a little table here, and we have to decide, well, what is angle A going to correspond to over here? And here you have to follow the image. If A has been rotated all the way around, then A is going to correspond to X, and B is going to correspond to Y, and C is going to correspond to Z. So we list all those correspondences. A corresponds to X, angle B corresponds to angle Y, and angle C corresponds to angle Z. And then you look at the side measurements. AB is going to be XY, and the order is important, and there should be a line over these guys because they are line segments. And we're not talking about the distances, we're actually naming the sides. So AC with the line over it, that's going to correspond to XZ, and again the order of the letters is important. BC is going to be YZ. And that's really all this is. This correspondence is just making sure you have the letters in the right order. Now, I lost a couple things here, and this means is ABC congruent to triangle XYZ? If everything corresponds and all the points map to from image to pre-image, or from pre-image to image, then yes, they will be congruent. Okay, so we say yes. All angles and sides have a congruent correspondence. So when angles are congruent and sides are congruent, then we can say the overall images are congruent. All angles and sides have a congruent correspondence. Okay. And then we want to decide what rigid motion mapped triangle ABC to triangle XYZ. And then we're going to write that in function notation. So the rigid motion that we used in our image, again, that mapped triangle ABC onto XYZ, was the rotation about P. Rotation about point P of 240 degrees, and we applied that to triangle ABC. So there's my function notation. We had a rigid motion, and here's kind of the meat of the lesson. This is pretty important. We're going to be saying this over and over and over again. Rigid motions produce congruent figures and therefore congruent parts. As a result, we can say that corresponding parts of congruent figures are congruent. Any image that undergoes a rigid motion, which means a rotation, a reflection, or a translation, is going to produce a congruent image. So let's look at the square next. ABCD is a square, and AC is one diagonal on the square. ABC, and we're going to say triangle ABC, is a reflection of triangle ADC, across segment AC. So that's how we create a square. Triangle ABC, I basically take this triangle and I've reflected across the diagonal to obtain ADC. And now we're going to write down all the corresponding parts. So complete the table below, identify the corresponding angles and sides. The order matters. So angle BAC, angle BAC, when I reflect over this line, it's going to be angle DAC. And this is the only way you can write it. It's the only way that's correct, angle DAC, because B corresponds to D, A corresponds to A, and C corresponds to C. So the next one, angle ABC. ABC is going to be corresponding to angle ADC. Think of the reflection, angle ADC. And then angle BCA, angle BCA. If that guy is reflected, remember the B is reflected down here, so he's going to be angle DCA. And then the corresponding sides, I need to put the little marks over them because that drives me crazy. Okay, AB, when you think of the reflection, AB, if I'm reflecting over that diagonal, he's going to reflect down here to AD. So AB is going to correspond to AD. BC, when you think of that line of reflection again, he's going to be DC. And you can't say CD, it's got to be DC, because B is reflected down to D. Now AC is actually the line of reflection, and he doesn't change. AC is going to remain AC. And then the next question, are the corresponding sides and angles congruent? And justify your response. Well, because we started off with a triangle, and we reflected that triangle through a line of reflection. That's a rigid motion, so it preserves angle measurements and side lengths. So the corresponding parts are going to be congruent to the original. So the answer is yes, because a reflection is a rigid motion. Actually, that'll be the answer for the next part. For this, we can say yes because they all have the same measurement. They all have the same markings. So the angles and sides have equivalent markings. And I'll explain what that is. By equivalent markings, I mean I have a right angle up here, I got a right angle down here. These tick marks are the same. So that means they all have the same length. So each little piece is congruent to the part that it's mapped to, which means that triangle ABC is congruent to triangle ADC. And that's because all the corresponding parts are congruent. Okay, because the only thing that's happened is it's undergone a rigid motion, which is a reflection. So yes, all corresponding parts are congruent. Therefore, the entire thing is congruent. The two triangles are congruent because the first one underwent a reflection over line AC. Reflections are rigid motions, therefore the two triangles are congruent. So now correspondence does not automatically imply congruence. If we look at the next example, where we have a little triangle and a bigger triangle, the relationship between the two, this bigger triangle is double the size of the little one. So here I'm going to use distance notation. So the length of AB times 2, I have to multiply AB times 2, and he's going to map to XY. BC, if I multiply him by 2, he's going to map to YZ. And then AC, if I double it, he's going to map to XZ. So I still have a correspondence. A corresponds to X, B corresponds to Y, and C corresponds to Z. And the other thing I have is that the angle measurements are going to be congruent. I'm just telling you that. I mean, you could measure it, you could see for yourself. However, my side lengths are not congruent. So just because we have a correspondence doesn't mean we have congruence. This going from here to here, we can't do that with any rigid motion. We cannot just reflect or rotate or translate and come up with a bigger image. So we do not have a rigid motion in this case. Is triangle ABC congruent to triangle XYZ? No, he is not, because the distances, corresponding parts, are not all congruent. And that's our answer. Corresponding parts are not congruent. Therefore, the overall image cannot be congruent. Okay, so corresponding parts do not always result in congruent figures. And we will practice more of this when we get together in class.